Hello everyone, my name is Anushri, 4th year BE in Information Science Engineering student at Sri Venkateshwara College of Engineering, Bengaluru. Today's topic of my presentation will be deep learning methods for multilingual classification of business documents. Contents will be introduction, related background, literature survey, working and implementation, results, application and future enhancement, conclusion and references. So introduction. With over 7,000 languages worldwide, most NLP models struggle with low resource languages affecting industries like legal, finance and healthcare. So we need a classification model which will efficiently classify the business document into finance, healthcare and legal documents. The increasing volume of multilingual business documents requires an efficient classification methods. Traditional rule-based methods such as statistical methods struggle with the diverse linguistic structures. Each of the language have a different grammar, semantics and structure. So traditional rule-based or statistical methods struggle with this diverse linguistic structure of a language. While the deep learning models have shown a particularly transformer-based models have shown a superior performance in handling the multilingual text. Related background challenges in multilingual text classification were variability in the grammar, syntax, and semantics across different languages. Like lack of available training data for low resource languages, complexity of training large scale language models. So, in previous approaches, the authors have used the statistical models such as naive Bayes, SPM, and decision trees, and also they have used the machine learning based models such as random forest gradient boosting. Deep learning advancements include CNN, RNNs, and transformers. This first literature survey, we have a docx classifier which is towards a robust and an interpretable deep neural network for document image classification. So this was published in the year 2024 September. So the methods or algorithms which are used in this paper are CNN, that is convolutional neural network, and the results were efficient like 94.19% top 1 accuracy on RVL CDIP dataset. This dataset includes the documents such as resumes, memos, and 95.971% top accuracy on Tobacco 3482 dataset. Pros were high document classification accuracy. Cons are focused only on English language datasets. In the second literature survey, we have the automatic register identification for the open web using the multilingual deep learning. This paper was published in the year 2024 in the June month. Methods and algorithms which are used here are again the CNN for multi-label classification using multilingual core corpus, which consists of datasets for different languages. So in the results, they have achieved around 79% accuracy F1 score across 16 languages, which is pretty good. Over 90% accuracy F1 score after data pruning. Data pruning is nothing but removing the duplicate data or converting the words into their base form. And in the pros, they have demonstrated a strong multilingual register identification. In cons, we have zero shot performance drops by 7% on unseen languages. So, what is zero shot performance? It is nothing but whenever we give a model while testing, we give some data for the model for testing, and it achieves the it correctly predicts the class even if we have not trained the model on this data. Means even if it has not seen that data during the training, it still predicts it as a correct class during testing. So that is zero shot performance, which drops by 7% on unseen languages in this case study. Next one, we have the amplifying document categorization with advanced features and deep learning. The authors have published this in 2024 March month, and the algorithms which are used are CNNs with embedding and pooling, long short-term memory for capturing long dependency, and advanced feature extraction techniques. Results were deep learning models outperform the traditional machine learning approaches in a text classification. Pros are captures the complex linguistic features and improves the classification through feature engineering. Cons include tested only on English language datasets. It is not a multilingual classification system. In the next one, we have the classification of text and non-text for from the bilingual document images using deep learning approach. And this paper was published in the year 2024 August. So the methods and algorithms which are used are unit architecture for segmenting and classifying the text or non-text regions in bilingual images. In the unit architecture is nothing but it is a method which is used in a deep learning models, in which we have mainly three parts, that is decoder, encoder, and also the bottleneck. While encoding, we pass that data or image into an uh, expansion which results into encoding of the text, and while decoding we compress the data and it is contracted, the image will be captured in decoding. And in the bottleneck, the highest level feature, that is obviously the image will be captured. So this is nothing but classification of text and non-text. Here the non-text will be an image. So they have efficiently achieved the accuracy about 99% accuracy for text versus non-text segmentation. Yet it does not align with our topic for today, that is multilingual classification of business documents. The pros will be high accuracy, useful for document automation in bilingual contexts. Cons are limited to binary classification, does not analyze the actual content which is needed. And we have the multilingual benchmark for document image classification. This was published in the year 2023 in the month of December. So evaluation of algorithms which are used are evaluation of visually rich document models on a new datasets, which is Wikipedia doc and multi-URLX doc in multi-label and zero-shot settings. Results expose the weaknesses of a document AI models in typologically distinct cross-linguistic scenarios. And pros are introduces the comprehensive multilingual benchmarks, supports the future research in cross-lingual classification. Cons include the notable performance degradation, limited generalization across languages. So working and implementation include data collection and preprocessing, feature extraction, model architecture, model training, evaluation, and deployment. In data collection and processing, dataset preparation is nothing but a collection of a multilingual business documents from CZEC public procurement contracts, which has around 50,000 plus records, which is the dataset. CZEC is nothing but it is a kind of a language similar to English, but most of the CZEC pronunciations which are there in CZEC language, we don't have those in English. For example, we might have a pronunciations which are pronounced in a different way in CZEC, but in English they are pronounced in different way. But it is a kind of a language which is similar to English, but it is driven from the Latin German. So pre-processing steps include tokenization. Tokenization is nothing but splitting a whole text or a sentence into words or a letters or a characters if needed. And stop word removal. Stop word removal is a process of removing the stop words which are the and stemming and lemmatization include converting the words into their base forms, such as when we say running, ran, we convert those into run, which is the base form of that word, which is ideally it is converted from the verb form to the noun form. So data augmentation techniques were used for low resource languages. Feature engineering, we have word embeddings such as fast text, word to vec, and multilingual word. Fast text is nothing but which processes the words in their base forms. Word to vec converts the words into a vector for numbers essentially. And multilingual word is nothing but it's a transformer based model to classify the multilingual business documents. Character level embeddings for handling various variations in the spelling can be used in feature engineering. Deep learning models used are CNNs that capture the local contextual features for classification. CNNs are most efficient and proficient from the image classification. So CNNs are used for local contextual features. And RNNs and LSTMs. RNNs is nothing but recurrent neural networks and long short-term memories. These RNNs learn sequential dependencies in the multilingual text. That is, if once a model learns it is a like if it predicts it is a wrong different class, and it gradually learns. So that those are used here to have a memory of what it had predicted earlier. We use the long short term memories. And we have the transformer based models such as mbert, that is multilingual BERT, and twhin BERT, which is Twitter heterogeneous information network, which is mainly based on twin BERT is mainly based on the dataset, which it is mainly trained on the dataset which is the web data or a Twitter data where we put the tweets. So CZB is nothing but CZ multilingual BERT. T5 is text to text transformer model, and their ability to handle cross-lingual tasks. So these are used in this author's paper. And model training and evaluation metrics which are used for training and evaluation are accuracy, precision, recall, and F1 score. Comparison of model performance across different languages can also be used. In these results, they achieved about 68% precision, 68% recall, and 68% F1 score for CPV sector classifier. CPV is nothing but common procurement vocabulary. So for this dataset, they have used the classifier, which is a rule-based classifier. Mainly, they have used the naive-based classifier. So they have achieved around 68% precision, 68% recall, and 68% F1 score. Google BERT multilingual plus fine-tuning the Google BERT multilingual model. They have got around 0.7 precision, 0.7 recall, 0.7 F1 score. TwinBERT plus fine-tuning. TwinBERT is nothing but a model which is trained based on the dataset which is extracted from the web data, or essentially the Twitter. Though they have got the precision around 0.7 and recall 0.7 and F1 score 0.7. CZB plus fine tuning, they have achieved a highest accuracy is based on this model, which is 0.8 precision, 0.8 recall, and 0.8 F1 score. Google BERT English plus Google Translate fine tuning. For in this, they have used the multilingual distinguishing of multilingual documents. So first, they convert the languages of different other languages other than English, like French or Spanish. They convert those languages documents into the English, and then they have processed using Google BERT English model and fine tuning based on that data set. They have achieved around 0.7 precision, 0.7 recall, 0.7 F1 score. Application and future enhancements. Current applications are automated classification of financial, legal, and corporate documents, language agnostic document retrieval and search systems, AI driven translation and summarization for global business operations. Future enhancements include integration with large learning models such as ChatGPT, DeepSeek for zero shot learning, improved domain specific multilingual NLP models, addressing the bias and fairness in multilingual AI systems. Coming to conclusion, deep learning models, as we already seen in the PPT, we have went through of these many models. As of now, like till now, what we have observed is deep learning models provides the robust solutions for multilingual business document classification. Transformer based models such as BERT, TwinBERT, transformer models outperform the traditional methods in handling the linguistic diversity. Ongoing research focuses on improving model efficiency, fairness, and adaptability. These are the references which I referred for this technical seminar. Thank you.